Now that you've had a chance to mess around with bcrypt in isolation, we're going to actually integrate password hashing into the Task Manager API. Now there are two main places where plain text passwords are provided to our application, and we can explore both by heading over to the user router. The first and the most obvious is right here, post users. This is when a user is created, and it's impossible to create a user without providing a password, so when someone is signing up, we definitely want to make sure to hash that plain text password. The next one is down below when a user is updated. Now they could be updated and have the password stay the same, they maybe just update the name, but there is a chance that a new password is provided, and if it is provided, we want to make sure we hash it. So these are the two places where plain text passwords might be provided to our application. Now, we're actually not going to change the code in here at all. Instead, what we're going to do is customize the user model. Mongoose supports what's known as middleware. Middleware is a way to customize the behavior of your Mongoose model, and it's going to allow us to do some pretty interesting things. To explore this, let's head over to the Mongoose documentation, and under guides, we have middleware. With middleware, we can register some functions to run before or after given events occur. So for example, validate. I could run some code just before or just after a user is validated. I could also run some code just before or just after a user is saved, and we have other events down below as well. In our case, we want to focus on save. Our job is to run some code just before a user is saved. What are we going to do? We're going to check if there's a plain text password, and if there is, we'll go ahead and hash it. Now, to actually get this done, we'll need to head over to the user model and do a little bit of restructuring to take advantage of this more advanced feature. When we create a Mongoose model, we're passing an object in as the second argument to model. That's the object that starts right here and runs all the way down to the end of our attribute definitions. Now, when we pass an object in as that second argument, behind the scenes, Mongoose converts it into what's known as a schema. In order to take advantage of the middleware functionality, all we have to do is create the schema first and pass that in. It's going to require about one line of additional code to get done, but once it's done, we'll be able to use more advanced features. So right here, what we're going to do is create a constant called user schema, and we're going to set it up by using the new operator with the following: mongoose.S schema, and we are going to pass to it an object which defines all of the properties for that schema. Now, that's just the object we have down below. So we'll take this object, the second argument to model, I'll highlight the entire thing, cut it out of its current location, and paste it right here as the first and only argument to the schema method. Now, when I do that, we have access to the user schema, and all we're going to do is pass that in as the second argument to model. So if we were to pass an object in, Mongoose was doing that behind the scenes anyways. In this case, we are creating a separate schema and a separate model, and this is going to allow us to take advantage of middleware. So right here, what we're going to do is use a method on user schema to set the middleware up. That's user schema dot, and there are two methods accessible to us for middleware. We have pre for doing something before an event, like before validation or before saving, and we have post for doing something just after an event, such as after the user has been saved. In our case, we want to do something before, so we'll be using pre, and we pass to it two arguments. The first is the name of the event, that would be save in our case, and the second is the function to run. Right here, this needs to be a standard function, not an arrow function, because the this binding plays an important role, and as we know, arrow functions don't bind this. Now I will be using async await inside of here, so we can go ahead and set that up. And we also get access to an argument, which I'll talk about in a moment, called next. For now, let's just go ahead and name it. So inside of here, we have access to the value on this, which is equal to the document that's being saved. So right here, we're saying I want to do something before users are saved. This gives us access to the individual user that's about to be saved. Now, it's kind of annoying to reference this throughout our function, so what I'll typically do, though it's not required, is create a new variable. Const user equals this. Now I can access user down below, which is a bit easier to understand. Now let's take a quick moment to talk about next. The whole point of this is to run some code before a user is saved. But how does it know when we're done running our code? Now it could just say when the function is over, but that wouldn't account for any asynchronous process which might be occurring, so that's why next is provided. We simply call next when we're done. Right here, I'm going to call next at the end of the function. Now, if we never call next, it's just going to hang forever, thinking that we're still running some code before we save the user, and it will never actually save the user. So it's really important to make sure that next gets called. Now, right here in between, this is where we want to go ahead and hash the password. Before we do anything like that, let's go ahead and just use console.log to print a message just before saving. What we're going to do is fire off some operations from Postman and watch that message print in the terminal down below. With the program saved, I'll head over to Postman, and we're going to start by going over to the create user request. This is one of the two places where we can provide a plain text password, and if I fire things off, we can see what we get in the terminal. So first off, we'll note that things did finish. We have the data down below and our 201 status. And over inside of Visual Studio Code, what do I get? I get just before saving printing. And on user, I could access the various pieces of data that were provided for the user, such as the name, email, or password, and we'll do that in just a moment. Now, currently, things are not going to work if we were to try to update the user. So I just created this brand new user. Let's grab their ID and try to update something. I'm going to take the ID, bring it over to the update user request and paste it in up above. From there, we're going to change one of the attributes, and I can leave it as it currently is, where I'm changing the name to Jess. Now, if I fire that off, what are we going to see? Down below, things worked. The name is now Jess, and everything else looks as expected. The problem is that over in Visual Studio Code, we didn't get our message a second time. So certain Mongoose queries bypass more advanced features like middleware, which means that if we want to use them consistently, we just have to do a tiny bit of restructuring. So all we're going to do is head over to that update route in the router file. I have that just down below, and we're going to make a small change, a change to how we perform what's done on this line, the actual update process. The find by ID and update method bypasses Mongoose. It performs a direct operation on the database. That's why we even had to set a special option for running the validators. We can go ahead and do it the more traditional Mongoose way to make sure that our middleware runs correctly. We're going to replace one line of code with 3 lines of code, so not a big change. The first thing we need to do is create a variable, const user, and what we're going to do is find the user by ID, so it still starts off in a very similar way. I'll use await with user.findById, and right here we just pass that ID in, exactly as we had it before. Request.params.id, which was the value provided right here. Now we have access to the user, so we have access to an instance of our user model, and it's time to update the properties that are actually being changed. So for example, changing the name would be me setting user.name equal to the new value, like something else. Now in this case, we can't hard code us updating those properties because it could be a different set of updates every single time. So all we're going to do is iterate over our updates array, the list of updates that are actually being applied, and we'll apply them. Right here, we will use updates, which is an array, .for each to get that done. So we provide our callback function, which gets called one time for each update we're trying to apply, and we have access to the individual update field right here. Remember, updates was an array of strings, so what we're getting right here is a string. It would be something like name, email, password, or whatever field they're trying to update. Now what we need to do is correctly set the property on user. For that, we'll use bracket notation. So here I'm updating a property on user, but it's dynamic, so I can't type it out like name because I don't know what it is. It's stored on that update variable. So we use bracket notation to access a property dynamically. In this case, we're accessing the property whose name comes from the update variable. Now we're going to set that equal to the value the user passed in. So request.body, and once again, we can't use dot notation because we would have to explicitly know the property and it's going to change, so we'll use bracket notation like the following. This is going to achieve the exact same thing, but it's dynamic. So if the values they're updating and the keys they're updating change, it'll keep working over time. Now we could always take advantage of the shorthand syntax by grabbing this expression and taking it up above, removing the curly braces and pasting it in. And the last thing we do is something we've done plenty of times before. I just await a call to user.save, and this is where our middleware is actually going to get executed. Now that we have this in place, let's go ahead and actually make sure we get our message printing. So over inside of Postman, I'm going to run the exact same update operation, though let's change the name. I'll change it from Jess to Jessica. I'll fire it off down below. It does indeed work, and the name has indeed changed correctly. But over inside of Visual Studio Code, we're now getting our middleware running. So this is a small adjustment that's required in order to get middleware to consistently run. Now that it is consistently running, we'll do what we actually want to do, which is to hash the password, and that's going to happen right here. Now, the first thing we want to do is make sure the password is actually being changed. If the password is already hashed, we don't want to hash it again. We only want to hash the password if it's been modified by the user, and Mongoose gives us a really easy way to figure out if that's the case. So what I'll be doing is setting up an if condition. In here, this is where we'll hash the password, but only under the following condition: if the user has a modified password property. User.isModified is the method we can use, and we pass in the name of the field we're looking for. In this case, we're looking to see if password was modified. This will be true when the user is first created, and it will also be true if the user is being updated and password was one of the things changed. In here, we can actually hash the password, and we've done that before. I'll be setting user.password equal to a hash. I'll use await with the following, that is bcrypt.hash, not ash, and we're going to pass in those two arguments. The first is the thing to hash. I have that on user.password, and the second is the number of rounds, and once again, I'll use 8. So here we're taking the plain text password and hashing it, then using that hash value to override the plain text value. Now with this in place, the only other thing we need to change in this file is to import bcrypt. So up above, let's get that done before saving and running it. A new constant, bcrypt equals, we'll use require, grabbing the bcrypt.js npm module. Now we can actually test things out and make sure the password is getting hashed. So over inside of Robo3T, in the users collection, I have a few different users, all with plain text passwords. Let's create a fifth one right here. I'll be heading over to create user, and I'll be firing off the exact same request I fired off before, still providing the plain text password. When I send that off, what do I get? I get a 201, and down below I can see not a plain text password, but a hashed one. Now, for the moment, we're still going to send the password back as part of the response. Later on, we'll fix that, locking down the password even more. The goal for now, though, is to just hash it, and that's what we have. Now, over in the database, we should see the hash value showing up here as well, and if I refresh the collection, that is exactly what I have. That last user document does indeed have a password, but it is the hashed one we saw before. Now let's go ahead and update the user to make sure that works too. So I already have their ID of that old user as part of the request for update user over here. We ran that a few moments ago. What I'll do is change the name back to Andrew, but I'm also going to change that password. Right here, I'll set a new value for password, and I'll make the value something like test123, and then I'll use some special characters. Now, if I go ahead and fire that off, what are we going to see down below? I can see that things did work, and we now have a hashed password value. So when someone creates a new user or when they update their existing user, if a plain text password is provided, it is indeed going to get hashed. And middleware allows us to enforce that without having to add this password hashing logic into multiple places, like the two routes that are actually related to this situation. We just provide it once and it works everywhere. So that's where we're going to stop for this one, but before we go, there is a quick challenge I'd like you to work through. Your job is going to be to make a change to the task router. We have our patch request right here for updating a task, and what I'd like you to do is alter the logic we use for updating it. Now, currently we're not using any middleware for task, but if we were to, it would be nice to use methods that make sure that middleware actually runs. So we'll be doing the same thing here that we did for user. So your goal is to change how tasks are updated. Step 1, instead of using find by ID and update, you will first find the task. Then you'll use for each to apply all of the updates onto the task. Finally, you'll save it, and then you'll test your work from Postman. Make an update to an existing task and ensure that it gets applied correctly. So take some time to knock that out. Feel free to use what we did with the user router as a reference, and when you're done, come back and click play. How'd that go? Let's go ahead and kick things off together. Down below, we have the one line we had before. I'm going to comment that out, and instead, we'll go ahead and do things the new way. So first up is to find that task. I will create a new task variable, much like we did for the user router over here. And I'll use await with task.find by ID, passing the ID in, exactly like we had done before. Next up, we want to apply those updates. I'll be using updates.forEach to loop over them. We'll get access to the individual update, and like we did before, I'll be setting the property on task equal to the value they passed in, request.body, using bracket notation to get it dynamically. And the only other thing we needed to do was make sure to save the individual task, so await task.save, and we're done. I'll remove the old line down below. I'm going to save the file. Actually, I'll also remove the challenge comments up above. Now I'll save the file and we can test our work to make sure that updates still function. The first thing I'm going to do is get a task ID. So right here, I will read all of the tasks. I have a single one. I'll grab its ID and I'll change the completed value from true to false. I'll then head over to update task. I'll put that ID right inside of the URL and I will switch it from true over to false. So I'm only changing the completed property. Now, if I go ahead and send that off, down below, I do get my 200 status code, which is fantastic. And in the response body, I can see my updated task and everything looks correct. The other fields haven't been altered, and the one that I did update did indeed change, meaning that our code is still working, even though we've refactored it. That's where we're going to stop for this video. In the next video, we're going to continue on talking about authentication, and we'll move on to the next topic we're going to cover, which is the concept of logging a user in. We'll figure out how we're going to get that done. Let's go ahead and jump right in.